Hello everyone, my name is Teacher Dan. I will be your mathematics teacher in grade 8. So today we're going to study chapter 1, exponential notation. Are you ready? Very good. Understanding exponential notation. Exponential notation are used when very large or small numbers such as 2,390,000,000 and 0.00000000168 need to be written in a manner that is more easily to understand. Imagine how heavy or how big the earth is. How many atoms in a glass of water, or how small the proton is. Exponential notation uses a general format of a times 10 raised to n, where a is a number greater than or equal to 1 and a number that is less than 10, and n being the powers of base number 10. Hot tips. So the exponential notation is also known as scientific notation or standard form. So that do not get confused between exponential notation and scientific notation. They are the same. Example number 1. Write the following numbers using exponential notation. Letter A, 78 million. It's a very big number. We're going to express this in scientific notation, okay, by deleting all the zeros. Let's start. 7.8000000 times 10 raised to 7. How it came like this? At first, you have to know where is your decimal point. Okay? In this example, our decimal point is somewhere at the end. Where? Okay? Somewhere here. Putting decimal point there and adding another 0 to the right doesn't change the value of the given. It's still 78 million. Okay? Now, after knowing where your decimal point is, we can start moving. Since our decimal point is to the right, we have to move the decimal point to the left, towards left direction. So let's start. 1, 2, 3, 4, 5, 6, 7. So we move the decimal point 7 places to the left. Therefore, 78 million can be written or can be expressed in exponential notation as 7.8 times 10 raised to the power of 7. Letter B, 0.0000564. As you can see, our decimal point is to the left, in between of these two zeros. Okay? So after knowing where is your decimal point, start moving it. Since our decimal point is to the left, we have to move it towards right direction. Let's start moving it. 1, 2, 3, 4, 5, 5. 1, 2, 3, 4, 5. A decimal point must be placed in between 5 and 6. Somewhere here. By moving the decimal point 5 places to the right, 0.000564 can be expressed in scientific notation as 5.64 times 10 raised to negative 5. Example number 2. convert the following numbers written in the form of exponential notation into integer form. Example letter A, 4.32 times 10 raised to 5. Notice your power of base 10. It is positive 5. It would give you a hint that your given number is a big number. By writing it into integer form, you have to move your decimal point towards the right direction because your power of base 10 is a positive number. 1, 2, 3, 4, 5. Therefore, by moving your decimal point towards the right direction 5 places, 4.32 times 10 raised to 5 is equivalent to 432,000. Example letter B, 6.89 times 10 raised to negative 5. Look at the power of your base 10, negative 5. So therefore, 6.89 times 10 raised to negative 5 has a very small value. Since your power of base 10 is a negative number, you will move your decimal point towards the left direction. Let's start moving our decimal point to the left. 1, 2, 3, 4, 5. Therefore, 6.89 times 10 raised to negative 5 can be written in integer form as 0.0000689. Easy, right? Very good. So let's continue. Exponential notation for numbers between 1 and 10. The decimal point of a number between 1 and 10 does not need to move when written using exponential notation. When the power of base number 10 for any number is 0, it is equivalent to that particular number. A times 10 raised to 0. Remember, any number that is raised to 0 has a value of 1. So, A times 10 raised to 0, your power of base 10 is 0, automatically that is equal to 1. Multiplied by A is equal to A. 2.7 times 10 raised to 0. 10 raised to 0 is 1 times 2.7 equal to 2.7. Remember that any number that is raised to the power of 0 equivalent to the value 1. Let's continue. Example number 3. Write the following numbers using exponential notation. 6.53 is equivalent to 6.53 times 10 raised to 0. Letter B, 4.38 is equivalent to 4.38 times 10 raised to 0. For your homework, answer Test Yourself 1.1 of your textbook on page 3 to 4. I will repeat. For your homework, answer Test Yourself 1.1 of your textbook on page 3 to 4. That is questions 1 to 5. Did you get it right? Very good. I hope you learned something new today. Once again, I am your teacher Dan. Thank you for listening. Have a nice day. See you again. Goodbye.